This is section 5.2, right triangle trigonometry. Okay, we start with the definitions of cosine, sine, tangent, secant, cosecant, and cotangent. And what this says is that you have some triangle with angle A, and notice I can actually overlay it on the x and y axis, okay, with A at the origin, and then extend out to the right from the origin and straight up from the origin and create that triangle by connecting the three sides, the sides that I drew in along the x-axis and then up from there, and then connecting, that makes a 90-degree angle by the way, and then connecting the hypotenuse. Okay, so so from A you have an angle. Let me zoom in so those of us that are watching this video can see it better. All right, so you have an angle, and from angle A you have the side adjacent, which is along the x-axis, the side opposite, which is the vertical side, and then the hypotenuse. Okay. All right. So we define then the cosine as the side adjacent over the hypotenuse, whatever the lengths are. The sine is the side opposite, which would be in this case the vertical side, over the hypotenuse. The tangent, side opposite over side adjacent. Notice I'm not using x, y, and r the way it's written in your notes. We can if we want to, but I'd rather look at the location. The secant, which is the reciprocal of the cosine, by the way, is the hypotenuse over the side adjacent. The cosecant, which is the reciprocal of the sine, then would be a hypotenuse over side opposite, and the cotangent, which is the reciprocal of the tangent. The cotangent is the reciprocal of the tangent, so it'll be side adjacent over side opposite. Okay, and those are the definitions of our 6 trig functions. All right, so let's work an example. So the examples part B says, example 1, it says find sine, cosine, and tangent of angle B of a right triangle ABC with A equals 6, B equals 8, and C equals 10. Notice it's a right triangle, so it looks kind of like the one that I just drew, but this one, let me redraw, and I'll just fill in the numbers. So this is angle B that I have here. Well, where's side A though? Because angle B is capital B, and then we have little a equals 6, little b equals 8, little c equals 10. So all the angles are labeled with capital letters. So I have then little c is equal to 10. C is the hypotenuse. So I'm going to put the c there. I'm going to say c equals 10 on the hypotenuse. Okay. And then B and A. So B is opposite angle B. So I have B equals 8. Side B equals 8. And side A is going to be adjacent then to angle B. So side A equals 6. All right. And the way I drew my triangle, side B looks shorter than side A, but the way that the numbers are given to me, side B is longer. All right. So then I have angle C is the right triangle. And angle A is the other angle that I'm not looking at for this example, because I'm asked to find sine, cosine, and tangent for angle B. So from angle B, I have the side opposite is side B, and it equals 8. The side adjacent is length 6, and the side of the hypotenuse is length 10. Okay, so so the sine then is the side opposite over the hypotenuse. I'm going to put first OPP over HYP, just to make myself a note. Opposite over hypotenuse. And so I just fill in the numbers. The opposite side is 8. The hypotenuse over the hypotenuse is 10. That's 8 over 10, which reduces to 4 over 5. The cosine is adjacent over hypotenuse. And so that'll be the side which is 6 over 10. That'll be 3/5. And then the tangent is the side opposite over the side adjacent. Opposite over adjacent. And that'll be 8 over 6, which will be 4/3. So I have found sine, cosine, and tangent for this particular triangle. Okay, so notice you'll have to just draw yourself a triangle, and Remember, it's a right triangle. All right, number 2 says if cosine theta equals square root of 2 over 3 for acute angle theta, find tangent theta. So tangent theta is going to be, I'm going to write it, side opposite over side adjacent. Okay, if I'm looking at a right triangle, which I am. So what I'm going to do is I'm going to draw a triangle. Yeah, and when they tell me cosine theta is square root of 2 over 3, remember cosine theta is adjacent over hypotenuse. So the side adjacent to theta, I'm just going to label theta as one of the acute angles. Yeah, so they're telling me that the side adjacent to theta is the square root of 2, and the side, the hypotenuse is 3. And if I were to place those relative to theta, adjacent and hypotenuse is 3. Adjacent is square root of 2 and the hypotenuse is 3. Notice that I can find the side opposite because I need it to find what tangent theta is. I have the side adjacent, but I need the side opposite. Remember, tangent theta is opposite over adjacent. I'm missing the opposite side to theta, and I just need to find it. So I'm going to leave that for you all to do, and we'll do it during class. All right, let's look at part 2, special angles. So first is the 30, 60, 90 triangle. And of course, this will allow us to find tangent, all the 6 trig functions that were listed at the beginning, cosine, sine, tangent, secant, cosecant, and cotangent, of 30 degrees and 60 degrees. All right, so how do we do this? So we're going to draw an equilateral triangle with the sides 2. Equilateral means our other sides are equal. It also means all the angles are equal. By the way, if all the angles are equal, then it's each angle has to be 60 degrees because the total has to be 180. And split it down its height. So what I did is I drew an equilateral triangle sitting on one of its bases. So one of the bases is horizontal at the bottom. And then I'm going to draw height from the top to the bottom. Okay. And what it does is it actually bisects the bottom. So my sides are 2, but at the bottom I've split that 2 into 2 parts, 1 and 1. And then I've also created actually 2 right triangles. Yeah, and so I have a right triangle with. Let me fill in. So I have at the bottom corners of the triangle, I have 60-degree angles, and then at the top it's a 60 degrees, but I've split it into 30 and 30. And so really I have 2 identical triangles. Okay, I'm gonna just redraw one and kind of lie it on its side. So the 90 degrees, I'm putting that on the left, and then the 30 degrees over on the right. And then from the 90 degrees up at the top, I'm putting the 60 degrees. Okay, and then I'm going to put the numbers that I know. So between the 90 and the 60 degrees, there's a length of 1. That's the vertical side. Between the 30 and the 60, there's a length of 2. And notice again, I'm back to having to find that third side. Yeah, so I just need to find the third side and then figure out for 30 degrees, for the angle that's 30 degrees, what is the sine? Let's say, sine, which is opposite over hypotenuse. What is the cosine, which is adjacent over hypotenuse? And what is the tangent, which is opposite over adjacent? And then the secant, remember, is the reciprocal of the cosine. The cosecant is the reciprocal of the sine. And the cotangent is the reciprocal of tangent. And I can do the same thing with a 60-degree angle, right? I can find cosine, which would be the adjacent over hypotenuse. That one I can actually see already. The sine, which is the opposite over hypotenuse. Tangent, which is opposite over adjacent. And then the reciprocal functions, which are the secant, cosecant, and cotangent. All right, I'm going to leave that one there also. And again, we'll finish it off in class if we must. Okay, let's go on to the next page. And we're just going to set up this other one, which is the 45, 45, 90 triangle. And that'll allow us to find cosines, all the trig functions for the 45-degree angle. So draw an isosceles right triangle with leg equal to 1, and then find the trig functions. So an isosceles right triangle is just a right triangle with legs equal. So I'm going to draw a leg down and a leg to the right, and the legs are the same, and then connect them at the ends. And I've made a 45, 90 triangle. So I have a 90 degrees on the bottom left. Bottom right, I have 45 degrees. And at the top angle, I have 45 degrees. All right, and I've been told that the legs are 1. So each of those legs is 1. And then I just need to find the hypotenuse. And again, I'm going to construct my cosine from the for 45 degrees, either one, from adjacent over hypotenuse, and so on and so forth. In fact, let's find the hypotenuse. So remember, a squared plus b squared equals c squared. And my a and my b are my two legs, which are 1. So it's going to be 1 squared, which is 1, plus 1 squared, which is 1, equals c squared. So 2 equals c squared. So that means the square root of 2 is c, or the hypotenuse is the square root of 2. I now have all the sides that I need. So for either of the 45-degree angles that I look at, I can find the cosine, which is adjacent over hypotenuse. Let's do 1. So the cosine is adjacent, which is 1 over hypotenuse, which is square root of 2. Remember, though, that I need to, I can't have square roots underneath, so I need to rationalize. So I'm going to multiply that by the square root of 2 over the square root of 2. You guys remember rationalizing? And that'll give me the square root of 2 over 2. So rationalizing means you get rid of the square root on the bottom. Let's do the sine. All right, so the sine is opposite, which is 1 over hypotenuse. And again, that'll end up as the square root of 2 over 2 once you rationalize. Yeah? And then the tangent will be opposite over adjacent, the tangent of 45. Oops, I'm missing my angle. So the cosine, I should say the cosine of 45 degrees and sine of 45 degrees. And then tangent of 45 degrees, which is 1 over 1, which is 1. So we have found all those, right? And you'll do the same with the 30, 60, 90 triangle. Okay, I'm going to stop here and I'll continue on the next video.